All right, so for today, guys, we're going to be talking about constant rate of change. A constant rate of change is also known as the word slope. So when you guys actually get up into 8th grade next year, and you start taking, Algebra 1, or for some of you who might be just going into the pre-algebra class, the 8th grade algebra class, it is going to be referring to things as slope. The way that we identify slope or constant rate of change is through a change that's occurring in your y value, that's called the rise, over the change that's occurring in your x value, which is called the run. So I'm going to go ahead and write that down here for you. When we do our constant rate of change, and for now on, instead of saying constant rate of change, I'm just going to say CRC. It makes it easier, a lot faster for when we are actually writing things down. It's just going to be the change in your y value, the change in your y value over the change that occurs in your x value. And like I said before, this is known as the rise over the run. The rise over your run, when we refer to it as the slope. So you're going to be seeing it for both concepts today, both terminologies for today. When we think of something having a constant rate of change or a slope, I'll zoom in so you can see that a little bit easier when you're copying it down, we use the term called linear. So if I say linear, let me see here, where can I write? If I write the word linear, what word do you think of? Like, what word do you kind of see in this term linear? What's something you think of? A line, right? Linear just means that it's going to form a line. That's all linear means. It's a straight value or a straight path that's being formed when you're graphing it. It forms a straight line, okay? And it does so because it has a constant rate of change, or a continuous or consistent rate of change. You guys have seen that with proportionality. So all proportional relationships that you guys have talked about, those are considered to be linear. Every proportional relationship that we've talked about has been a linear representation. Now, not all linear representations are proportional. Remember, some of our proportional or some of our non-proportional graphs started at a different value other than 0, 0. They were still proportional, or still had a constant rate of change because they still had a unit or a rate that they were changing by consistently, but they started at a different value other than 0, 0. Okay? What we're going to look at for here today is a couple of tables and how to find our constant rate of change. So when we're trying to find our constant rate of change, what we're going to be doing is we're going to identify the CRC by finding how much our y values changed by over how much our x values are changing by. Now, don't forget, I also told you guys before that there are two ways that you can represent an XY table. You have what's called a vertical table, where X is on the left side and Y is on the right side. That's a vertical table. Or you have a horizontal table, where X is on the top and Y is on the bottom. That's called a horizontal table. So just make sure to know the setup where X and Y is located on vertical tables. So this is a vertical table, this is a vertical table, and then horizontal tables, these are horizontal tables, okay, because they're running left and right. All right, so for here on this vertical table, the time value is representing our X value, and the amount of money earned is representing our Y value, which makes sense because 2 days ago we talked about how your money is always your Y and time is always an X value, okay? Now, when we're talking about the change that's occurring, I'm looking at these numbers and going, okay, I'm starting at 10 and then I'm going to 30. So am I increasing or decreasing? Increasing. So from 10 to 30, I'm going to increase. And what am I increasing by? 20, right? If I do 10 plus 20, that's going to bring me to 30. What about from 30 to 50? I'm going from 30 to 50. What am I doing? Adding 20 again. So I'm going to put a positive sign, or increasing by 20. It's moving by a positive. And then from 50 to 70, what's happening? Plus 20 again. So there's my change. This is my actual change that's occurring here. What I'm showing on this side is the change that's going from my y value to my y value to my next to my next. So my change of y is a positive 20. I want to make sure I'm indicating that it is a positive. Okay, let's take a look at the x values. My x value goes from 1 to 3 to 5 to 7. So am I increasing or decreasing? Increasing. So when I'm going from 1 to 3, I'm increasing by how much? By 2. When I go from 3 to 5, I'm increasing by 2. When I go from 3 to 7, I am increasing by 2. So this is considered to be the change. This is your change for your x value. So underneath, on the bottom of our fraction, we're going to put a positive 2. So we have a positive 20 over a positive 2. Do we ever leave our fractions looking like this? No. Why not? Improper is okay. From this point on, improper fractions are perfectly fine. You want to keep them as improper fractions if they are improper. You want to leave them like that because remember, your slope or your change is a fraction. It's not a mixed number. You want to leave them as impropers. But is this simplified? No, they both can be simplified. They both could be divided by 2. They both can be simplified by the value 2. And you can always plug it into your calculator, put 20 over 2, and you're going to get 10. So what this means is our constant rate of change is $10, right? Because the change of y represents the 10. Change of y is 10, and that's money. $10 per 1 hour. That's our constant rate of change. Every hour we're increasing by $10 or we're earning an extra $10. There's our CRC. Okay? Let's take a look at problem number 2. So again, first thing I want to do is identify which one is my x and which one is my y. Tickets, is that my x value or my y value? X. Right? Remember, look at our tables. Our tables are set up as X, Y. X on the left, Y on the right. So the tickets is going to be my X value. So I'm going to put an X up above it. That means the cost, money, that's my Y value. Okay, the first thing that we want to identify is the change that's going to happen in those Y values. Because remember, we need to identify the change of our Y, and we'll put it over the change of our x. Okay, we're going to identify the change of the y over the change of the x. So who can raise their hand and tell me what are we changing by from each of these y values? We're going from 15 to 45 to 75 to 105. Daniel? Huh? 30. And are we adding or subtracting? Adding, right? We're increasing. Each one of these is increasing by 30. Each one of these is increasing by 30. So our change is going to be a positive 30. Okay, for our tickets, we're going from 1 to 4 to 7 to 10. What's the change that's occurring there? We're going from 1 to 4 to 7 to 10. We're going up by 3. Thank you. So the change that's occurring for those x values, it's an increase by 3 each time. Each time we're increasing by 3. So that's a positive 3. All right, 30 over 3. What can we simplify it to? Put it in your calculator. Put 30 over 3. Hit enter. What does it come out to? Zarina? 10. Good. And so this is 10. And remember, it's 10. Go back to your y. What does y represent again, guys? the cost. So that's money. So it's $10 per ticket. Thank you, Angel. Per one ticket. So if you need a reminder, it's always a Y per X. You're always going to be writing this as a Y per your X. So it's $10 per one ticket. That's going to be our constant rate of change. What I want you guys to do right now is problem number 3. But before we do that, who can raise their hand and tell me which one of these is going to be the X value? Is it the number of trees or the number of apples? George? Number of trees. Very good. Number of trees is our X value because, again, our horizontal tables are written with the X on the top and the Y on the bottom. But be careful, because a common mistake that people make with these horizontal tables is they put that change of X on top and the change of Y on the bottom. But remember, it's change of Y over change of X. So don't get confused by those horizontal tables. Number of trees is your X. Number of apples is your Y value. Go ahead and identify the CRC. Don't forget to simplify it as well. All right, let's go over this. Let's talk about the different changes that are going to be occurring here. Let's start with the change of our Y because that's what we know needs to go on the top. Our change of Y is what we are going to be focusing on first. Who can raise their hand and tell me what our Y value is changing by? Jeremy? Well, so what is the Y value changing by consistently? It's adding 100. Each time we're adding 100. We're increasing by 100 every single time. So the change of our Y is going to be a positive 100. Okay, what about for the change of our X? What is our X consistently changing by, Yara? 5. We're increasing consistently by 5 every single time. So it's a change of 5. Now we want to simplify it. When we simplify it, it simplifies down to a 20. What does that represent? 20 what? Kyle?
20 per one tree.
But what is it? Is it 20 trees per one apple? Is it 20 apples per one tree? What is it going to be?
Trees. I meant 20 apples.
20 apples, right? It's because it simplifies basically to 20 over 1. But this was our Y and this was our X. So it's 20 apples per one tree. So you have to relate it. It's your Y per X. It's always your Y per your X. So this is 20 apples per one tree. 20 apples per one tree is your constant rate of change. All right, go ahead and flip it on over to the back. And what we're going to be doing in just right now is we're going to watch a quick little video, and I'm going to give you a fair warning that the video is pretty lame. We're going to pause for a second. Now, as silly as the video is, I'll tell you, every year that I've ever shown it, it helps. It's silly and lame, but it actually does help when you're trying to memorize what the types of slopes look like when you're graphing them. So these are slopes. Like I said, constant rate of change, another word for that is the word slope. So what he was talking about, when you're trying to go uphill, it's hard work, isn't it? If you've ever, maybe you haven't skied, but if you've ever ridden a bike and you're going uphill, you got to put a little bit more work into it, don't you? And if you're real young and you've just started learning how to ride a bike, it probably is difficult to get up a hill because you haven't built that strength up yet. So that's why he was saying it's hard work, so it's puff, puff, positive. This is a positive slope, and I'll even write puff, puff, positive. This means that when you are graphing a line and it's going in what looks like an upward direction from left to right, it's a positive slope. When you are going towards the downhill part, it's easy to do. Like, again, if you're riding your bike and you're going downhill, do you have to pedal to move?
No.
No. And it'll keep increasing your speed too, right? As you're going downhill, your speed's going to get faster and faster. It's easy to go, and a lot of people like going downhill because it's that speed. So it's nice negative. This is a negative slope. So I'll even put nice negative. It's easy to remember. It's an easy ride. Okay, then you get to this flat part. The flat part, he said, is zero fun. Maybe when you're riding a bike, it's not that big of a deal, but if you're walking through the snow, it's boring. Okay, especially if you got the skis on. It's not fun at all. So that's why it's called zero. It's a flat horizontal line. You have absolutely no incline. There's no going up, there's no going down. It's just flat and zero. So it's zero fun. And then the straight vertical line. A straight vertical line is what's going to cause that word undefined. And the reason it's undefined is because you're trying to divide by a value of 0. And remember I told you guys 2 days ago when we were talking about constant of proportionality, and I always said, hey, ignore that first point where it says 0. Ignore it. It's because you can't divide by a 0. If you were to take a fraction and put any number, I'll say 9 over 0, and I hit enter, it's going to say that you're having an error. It's a division error or a syntax error because you cannot divide by a 0. It's not able to happen. So we call that situation an undefined slope. So I'm going to tilt this for a second and write down undefined. So this is the slope for a vertical drop, undefined. You want to make sure you have those all written down. Now, again, it's not going to look like this kind of diagram. When you graph them, they're going to be actual graphs. So that's why I have these little grids here. A positive slope can look something like this. That's a positive slope. A negative slope will look like this. A 0 slope, again, it's just a flat horizontal line. 0 slope. And then our undefined is a vertical line, a straight drop. That's called undefined. So, like I just said, again, it's not always a table that is going to be doing a constant rate of change. Sometimes it might be from a graph, but again, we can call that slope or rise over run. So what I want you guys to do is just draw a grid on your paper. Shh. Draw a grid anywhere on your paper, on your graph paper, okay? And I want you to plot the following points. And I'm going to make it as an XY table for what you're going to plot. You're going to plot the points 3, 7. You're going to plot the points 0, 5. You're just plotting the points. You don't have to worry about connecting it yet. I want you to plot the points -3, 3. And then that's it. Just plot those 3 points, 3, 7, 0, 5, and -3, +3. Plot that on your grid that you just made. All right, so based off of how I've graphed them, Is this going to create a positive, negative, 0, or undefined slope? Is it positive, negative, 0, or undefined? George? Positive. This is a positive slope. So I'm going to go ahead and I'm going to connect them. You don't have to connect them yourself. You can just be able to look at that. But I'm going to connect them real quickly with it's a positive direction. See how it's going up in a positive direction? Now, I made the table this way because I wanted you guys to see that when we do our change of our x happens to be decreasing by 3, doesn't it? But so does our y. Our y happens to be decreasing by 2. So when we do our change of our y being a negative 2 over the change of our x being a negative 3, a negative over a negative is what? What's a negative over a negative, guys? A positive. So this is a positive 2 over 3. So this would be our slope, or our constant rate of change. Our slope is going to be 2/3. Let me show you, again, using just the graph now. This is what you would have done for the table. And I'll zoom on into that for just a second so you can see it easier. This is how we would have done it for the table. We found our change of our y over our change of our x, and we get a negative 2 over a negative 3, which is just 2 over 3. That is our slope, or our constant rate of change. Here's what it looks like if you were to follow it on just the graph. You pick any point on the graph. It doesn't matter which one you pick. So I'm going to start at the first one, and I'm going to find my change of y. Does my y go up and down or left and right? My y. Does it go up and down or left and right?
Up and down.
Up and down. It goes up and down. Think of it. Here's how I always tell kids to remember. If you're looking at the letter X, how many legs does the X have?
4.
2. Has 2 legs, so it can go running. Running moves left and right. How many legs does a Y have? 1. So it can only hop up and down. Okay, so your Y goes up and down. Your X goes left and right. Your Y can hop. Your X can run. So I pick any point I want, and I'm trying to get to the next point. So to go from my first point to the next point, I have to go up. I'm going to go up 1, 2. Then I'm going to do my X value, my run. 1, 2, 3. There's my change of Y. There's my change of X. 2 over 3. Everybody clear? So when you're given a graph, you can do the same thing. You see how far up or down your Y goes, and then how far left or right your X will go. So I'm going to give you guys another problem. You can do it on the back of this graph paper that you have. Okay, so I'm going to flip it on over to the back, and I'll go back to that front one in just a moment. But I want to just give you a quick problem. So what I want you guys to do is I want you to graph points at, we'll say, -2, +2. Then we're going to go 1, 2, 3, 4, 5, 6. Over to 1, 2, 3, 4, 5, 6, 7. Then you're going to go to -6, +7. And then we'll put another one over at +2, negative 3. Positive 2, negative 3. Okay, so this is at 6, sorry, negative 6, positive 7. This is at negative 2, positive 2. And this is at a positive 2 and a negative 3. I want you guys to go ahead and find out what is the constant rate of change or the slope given this table, or I'm sorry, this graph. All right, so again, we're going from one point to the next point, or from this point to this point. We want to know what is the change in the y over the change of the x. Who can tell me what is the change of the y going to be? First of all, if I start at my first point, am I going up or down?
Down.
Down. How much am I going down to get to the next point?
4.
Let's count. 1, 2, 3, 4. Nope, not enough. 5. So we are decreasing by 5. Same thing here, decreasing 1, 2, 3, 4, 5. We are decreasing by a 5, so that's a negative 5 for my change of my y. Then for my x, is it increasing or decreasing to go from one point to the next? Increasing. We're going 1, 2, 3, 4. That's a positive 4. Here, 1, 2, 3, 4. That's a positive 4. So it's going to be a negative 5 over a positive 4, which is just negative 5/4. That would be our constant rate of change, or our slope, a negative 5 over 4. Tomorrow, when you come in, we're going to do the same thing that we did today. You're going to have a quick quizzes assignment at the very beginning of class.